Section 1.1 Linear Equations. An equation is a statement that two expressions are equal. So look at the example of these equations. First one, x plus 2 equal to 9. Okay, we do have the variable here and they equal to each other. The left hand side has to be equal to the right hand side here. Okay, so this is gonna be our equation. We do have a one equal side here. To solve an equation means to find all numbers that make the equation a true statement. These numbers are the solutions or the roots of the equations. Like this one, I could solve for my x. I can subtract 2 for both sides and then I find it out my x is going to be equal to 7. And x equal to 7, we call this is the solution of this equation. Or you could say this is the roots of the equation. A number that is a solution of an equation is said to satisfy the equation, and the solutions of the equations make up its solution set. Equations with the same solution set are equivalent equations. Addition and multiplication properties of equality. So we're gonna let A, B, and C represent the real numbers. If this is the true statement, A equal to B, then we could add C for both sides. They are still equal to each other. Okay, you're gonna add C on the left hand side and then you're gonna add C on the right hand side. And this is still equal to each other. And this is called the addition properties of equality. Multiplication properties. So if A equal to B and C is not equal to 0, then when you multiply the C for both sides, they are still equal to each other. Okay, this is the multiplication properties. Linear equation in one variable. A linear equation in one variable is an equation that can be written in the form ax plus b equal to 0. A and B, we consider this is gonna be the real numbers. And with A is not equal to 0. So we only have a one variable. The variable will be the x in here. Linear equation is also called a first degree equation since the greatest degree of the variable is 1. For example, we only have a one variable here, that will be the x. The degree of the x is going to be 1. The exponent of here, that's only 1 here. So that's why we call this as a linear equation. Like here, variable of x is also 1. The highest degree of the variable is 1. This guy also, I have a 1 here and 1 here. So this is the first degree equation. And we also call this as a linear equation with one variable. Okay, look at this example. Square root of x. Think about it. Is it the first degree? No, right? Remember from the previous sessions, we learned that square root of x, we could rewrite it to x to the power of 1/2. Okay, x to the power of 1/2. So the degree is not equal to 1, so this is not the linear equation. This one, 1 over x, we could rewrite to x to the power of -1. X to the power of -1. So exponents become -1, that's not equal to 1. So this is not the linear equations. And this one, obviously, the degree is going to be second degree. Right? Second degree, so this is not the linear equation. So these three examples, we call this as nonlinear equations. First example, solving a linear equation. So we try to solve for the x in here. Double check, this is only first degree. This is the linear equation with one variable. Okay, so what we're gonna do? First, distributive property. we want to distribute the 3 for both of them. 3 times 2x minus 3 times 4. And also, on the right hand side here, this is 7 minus, we're going to distribute the negative 1 here. They don't put the 1 here, but we know that this means negative 1. So negative 1 times x and negative 1 times plus 5 here. So you're going to get 6x minus 12. And we're going to distribute the negative 1. So negative, positive become negative. Okay, be careful the negative side here. Now, we're going to combine the 9 terms. So on the right hand side, we have a 7 and 5. This is the 9 terms. So 7 minus 5, that will be equal to 2. Now we want to isolate the x. Okay, so we have a 6x here. We have the negative x here. So we're going to add x for both sides. And then combine the 9 terms here. That will be 7x minus 12. This one we cancel out, only left with the 2. Okay, last step here. We're going to combine the constant terms here. So we're going to add 12 for both sides. So you're going to get 7x equal to 14. And then divided by 7 for both sides. You're going to get x equal to 2. Okay, right? This is how you guys solving a linear equation. After you guys find x equal to 2, you always can track the work. Remember how to track your work? You can put it back to the original questions here. Okay, let's check the work together. This is the original equation. We find it out, x is going to be equal to 2. So let's plug it in to see if they are equal to each other. So you're going to get 2 times 2, which is going to be 4 here. And this is 2 plus 7. And this is 2 plus 5, which is going to be equal to 7. So that will be 0 equals 0. And this is a true statement. So we know that the solution set is x equal to 2. Okay, example 2. This time we do have a fraction here, right? This is the fraction. So what we want to do, first, we're going to find out what is the LCD. Okay, we have a 3, 2, 4, 3. And what is the LCD? The least common denominator. It should be equal to 12, right? Now, we're going to multiply the LCD for both sides. Or you could say to multiply the LCD for each of the fractions. Now, you're going to distribute 1 by 1 here. Distribute 1 by 1. Okay, if you can handle it, you could just skip this step. And then now, you're going to divide it by 3 here, divided by 3 here. You should get the 4. And divided by 2, divided by 2, you're going to get 6 here. Divided by 4, divided by 4, you're going to get 3 here. Divided by 3, divided by 3, you're going to get the 4 here. Okay, right? So now you're going to distribute this one also. Okay, combine the 9 terms. So xx plus 6x, you're going to get 14x. And then you're going to subtract the 3x. You want to isolate the x. So at the same time, you could subtract the 16 for both sides. And then at the end, you're going to divide it by 11 for both sides. you should get x equal to negative 4. One more time, you always can check your work during the exam. After you find it out, you're gonna put it back to the original equation here, okay, to see if you're gonna get the true statement. Okay, identities, conditional equations, and contradiction. An equation satisfied by every number that is a meaningful replacement for the variable is an identity. So, for example, this is the equation. If I distribute for the 3, I'm gonna get 3x plus 3. So 3x plus 3, this is equal to 3x plus 3. And then no matter what you put for the x here, you're gonna get the true statement. When I put the 0 here, 0 plus 1 is just 1. 1 times 3 is 3. When I put the 0 here, it's just equal to 3. This is the true statement. So we call this as the identity. And the solution set is all real numbers. It means you could put whatever you want for the real numbers into this equation. You're going to get the true statement. Okay, I need you guys remember when you get the true statement, for plugging any real numbers here, this is called identity. Second one, conditional equation. So I have this equation, 2x equal to 4. I should be able to find out the x, right? I could divide it by 2 for both sides. You're gonna get x equal to 2. Okay, we only have a one solution in this equation, x equal to 2. So we call this is the unique solution. And also, we could say this is a conditional equation because we only have a one solution here. Last one, an equation has no solution is a contradiction. For example, I have an x equal to x plus 1. If I try to solve for my x, I'm gonna subtract x for both sides. You're gonna get 0 equal to 1. And 0 equal to 1, this is a false statement. So we say this is no solution. Okay, and we say the equation is a contradiction, and that makes it like no solution. Okay, one more time. Identity means you could put in all real values to get the true statement. Conditional equation means you only get unique solution. And contradiction means you're gonna get no solution. No matter what you put the value for the x, you're gonna get the false statement. Example 3. Identifying types of equation. Determine whether each equation is an identity, a conditional equation, or a contradiction. I want you guys try, and then we're gonna check the word together. So first, we're gonna apply the distributive property. Right, you're gonna distribute the negative 2 to the x and then distribute the negative 2 to the 4. So you should get this negative 2x minus x plus 3x equal to x minus x. And then combine the 9 terms. Look at the left hand side. We do have a negative 2x plus 3x. So combine the 9 terms. You're gonna get this guy. Okay, you could stop at here, or you can keep simplifying. So we could subtract the x and add the x for both sides. You're gonna get 0 equal to 0. So this is always the true statement. And then we know the equation is gonna be an identity. right? Because the solution set is all real numbers. No matter what real numbers you plug in here, you're gonna get the true statement. So this is the identity. Okay, next one. Try. We're gonna add 4 for both sides here. And then divided by 5 for both sides. You're gonna get x equal to 3, right? So we find the unique solution. X is equal to 3. So this is a conditional equation. Okay, last one. Distribute the 3. You're gonna get this guy. And then I'm gonna subtract the 9x for both sides. So I got negative 3 equal to 7. And this is a false statement. So that means this is a contradiction with no solution. Okay, this is gonna be the summary, the types of the linear equation. One more time, when you get the true statement, this is identity, solution set will be all real numbers. When you find it out what is your x, this is a unique solution and the equation is conditional. So the solution set consists of a single element. From this example, x is gonna be equal to 3. And if you're solving a linear equation and get the false statement, then the equation is contradiction. So the solution set is empty. That means no solution. Solving for a specific variable. A formula is an example of a linear equation, and this is the formula for simple interest. Remember the simple interest formula? Like, for example, you deposit $500 to the bank. The $500, we call that's a principal. And then let's say we're gonna get it back like after 1 year. So after 1 year, the bank gonna give you back the $500 and also with the interest. Okay, so this is the simple interest formula. The I here, this is represent the interest. How much extra you're gonna get if I put the money into the bank after 1 year. And then the P here, this is gonna be the principal. How much money you put into the bank. So our example is gonna be your $500, right? And then the R, this is talking about the interest rate. Okay, what is your interest rate here? And the T here, this is represent how long did you deposit the money to the bank. And then the unit for this T, talking about the years. You could put 1 year, 2 years, or 3 years. Let's say if you only put like 6 months, so the T is gonna be 1/2. Okay. Solving for a specific variable. So we do have the simple interest formula. But right now, I may want to solve for the t. I want to know what is t equal to. So we want to isolate the t on one side, okay? We want to get out of the p and r. So what we're gonna do? This is a multiplication, right? Multiply. So we're gonna do the division. Divide each side by p and r. And then these two guys, you could cross it out. So T will be equal to I over PR. Okay, so this is how you solve for the specific variable. Another example. So you could see we do have a more than one variable here, the x and a and b here. And I want you guys solve for the x. Okay? Solve for the x. So first, distributive property. You're going to distribute the 3 for the 2x and also the 5a. And then you're going to look at it. On the left-hand side, do we have any terms that we can combine? No, right? They are not the like terms. Right-hand side, nothing. So I want to isolate the x terms on one side. So we're going to subtract the 4x for both sides. And at the same time, we could add the 15a for both sides and then subtract the 4b for both sides. So you should have this guy here. And then combine the like terms, which is going to be 2x equal to this guy. We want to solve for the x, right? So we're going to divide it by 2 for both sides. So this is going to be your x equal to. Okay, last example. Applying the simple interest formula. A woman borrowed 5,240 for new furniture. She will pay it off in 11 months at an annual simple interest rate of 4.5%. How much interest will she pay? Okay, so we're gonna using this simple interest formula. So first, your R here, this is talking about the interest rate. That would be 4.5%. Okay, you don't just put in 4.5 here. Okay, 4.5%, you're gonna do 4.5 divided by 100. And then P, that would be your principal. So the principal is gonna be 5,240. The T represent the year. How many years? Oh, she only pay it like in 11 months, right? So the T would be 11 over 12. Okay, one more time. Interest rate, that's a 4.5%. So you're going to divide it by 100 here. Principal, that will be your principal. The unit of the time will be the year. So 1 year, we do have a 12 month. So we're going to put 11 divided by 12 here. So plug it in. Feel free to use your calculator for this kind of the question. You should get $216.15. So she will pay $216.15 interest on her purchase. Okay, that's it.